7.5. Rational exponents and radicals. Number 1 is asking you to rewrite without rational exponents and to simplify if possible. So, when we have a variable raised to an exponent and it wants us to rewrite as a radical, we need to identify something first. In the fraction, the numerator and denominator both mean something. The numerator represents the power, or what the expression is being raised to. This one is being raised to the first power. In the denominator, it is the root that it is. Since this is 6, this is all being taken to the 6th root. So writing it with radicals, we put x inside the radical. It's being taken to the 6th root, and the exponent or power is 1, so we don't write that. So we'll just have it looking like this as our answer. So let's type that in. So I'm going to click this one. So I put 6 up top for it being the 6th root, and x goes inside. So my answer would be the 6th root of x. That is number 1. Number 2, it is asking you to find the 4th root of 256. Basically, it is asking you what number times itself 4 times gives you 256. So let's take a closer look at this. If you don't know what number times itself 4 times will give you 256, you can always rewrite this with fractional exponents, and then we can put it into the calculator. So this one is a 4th root, and we don't see a power anywhere, so it will be a power of 1. So the power goes up top in the fraction, the numerator, so that is 1. The root at the bottom, so 1/4 will be the fraction it's being raised to. So that we could type in the calculator, and when we do that, we get 4. So 4 times 4 times 4 times 4 gives you 256. So let's type that in. So typing in 4, that is our answer. Number 3, it is asking you the 3rd root of 27. That is the number that times itself 3 times will give you 27. We can rewrite this as a fractional exponent to put it in the calculator. So let's show you that. So we have a 3rd root, so that goes at the bottom of a fraction in the denominator. And we have no power being risen larger than 1 because we don't see it. So our numerator will be 1, denominator will be 3, so 27 to the 1/3. So if you type that in, you will end up getting 3. So 3 times 3 times 3 is 27, and that will be your answer. So we'll type in 3. That's our answer for number 3. 4, it is asking us to write this expression in radical form. We have 144 x to the 1/2 power. So let's take a closer look at that. Notice how there is not a 1/2 power on the 144, just on the x. That means we're not going to touch the 144, but we will have to rewrite the x to the 1/2. Remember, in a fractional exponent, the numerator represents the power, the denominator represents the root. So we have it being raised to the first power, and the 2 means it's going to be a square root. So we don't write a first power, but we would write radical x for square root. So your answer is just going to be 144 radical x. So typing in, we'll have 144 radical x. And that's the answer for number 4. Number 5, it says to write the expression in radical form. Let's take a closer look at it. Notice how the entire expression is being raised to the 1/2 power. That means I'll raise both the 64 and x to the 1/2 power. So we know already that with the fractional exponent, the numerator is the power, the denominator is the root. So we have a power of 1, a root of 2, so square root. So let's bring 1/2 into all of that. So we're going to put all this in the square root. So we have the square root of 64x. Now I can simplify that because I can find the square root of 64. This is a perfect square. Square root of 64 is 8, so I bring that out. I'll leave the x inside the square root because I can't take the square root of it. So my answer is going to be 8 square root of x. Typing that in, I'll have 8 radical x. That is number 5. Let's go on to number 6. Number 6, it is asking you to write this expression in radical form. Now this one is going to get a little tricky. Just follow closely with it, and I'm going to go step by step on how to do it. Now normally what we would do is simply raise each of these to the exponent, which in this case is 2/3, and call it a day. But when I do 24 to the 2/3 power, I do not get a nice answer, which means I simply cannot just bring these to the power and be done with it. I'm going to have to use a little bit of a trick first to simplify it down. First, we have to remember that when we have an exponent with fractions, the numerator represents the power that it's being raised to, and the denominator is the root. So we have a power of 2, a root of 3. Now I'm going to zone in on the root of 3. What I'm going to do is look for a factor of 24. That is a number that multiplies to 24. That is a perfect cube. For a number to be a perfect cube, there has to be a number that times itself 3 times will give you that number. So now what we're going to do is look at our factors of 24 and see if any of them are perfect cubes. So I'm going to go to y equals, I'm going to type in 24 divided by x, and type in second graph. Starting with 1, 1 is a perfect cube because 1 times 1 times 1 is 1, but it's not really going to do anything for us. We want a number aside from 1. I'm going to show you how to check the rest of the numbers. So let's try 24. So go to second, click to go back here, and go to math, go down to number 4. Here is cube roots. So if we type in 24, I get a decimal. That tells me it is not a perfect cube. Let's check my next one. Go back to my table. I can check 2 and 12. So math 4. 2 is not going to work. Go to math 4 and 12. 12 is not going to work. So let's look at 3 and 8. Math 4. We'll type in 3. Does not work. Type in math 4 and try 8. 8 is a perfect cube, and that number would be 2. 2 times 2 times 2 is 8. So now I'm going to go back and show you how to use that. Now that we found that 8 is a perfect cube factor of 24, what I'm going to do is expand this. What I mean by that is I'm going to write this as two numbers being multiplied. And the two numbers that multiply to 24 involving that 8 will be 8 times 3. So I'm going to write this as 8 times 3c. Just put the c over with the 3 because you cannot take the cube root of just c. So summarizing what I just did, I rewrote 24c as 8 times 3c because I found that 8 is a perfect cube and I need that in order to simplify this. So let's continue from there. Now I'm going to rewrite this 8 with an exponent. Now we know that the cube root of 8 is 2. And we know 2 times 2 times 2 is going to be 8. So I'm going to rewrite 8 as 2 to the 3rd power because I want that cube as an exponent. So going from there, I am now going to raise each of these to the 2/3 power. Now when I raise an exponent to a power, I multiply the exponents. Since 3 is also my denominator here, a number, whole number times a fraction's denominator will give you just the numerator. So 3 times 2/3 is just going to give me 2. So I'll have 2 squared. And everything else is just going to be raised to the 2/3 power for now, because I'm going to have to do a little more with that. 2 squared is 4. That we know. Now at this point, we have all this being raised to the 2/3 power. So like earlier, remember that The numerator is the power, and the denominator is the root. So we have a cube root, and the cube root of all of this squared, because the exponent is 2, so all that's going to be squared. So we have the cube root of 3 squared and c squared. Raise each of these to the second power. 3 squared is going to be 9. So you have 4 times the cube root of 9c squared, which, simplifying that even further, will be 4 cube root of 9c squared. And that's going to be your answer. So I'm going to type in 4 cube root of 9c squared. And that's my answer for number 6.